All right, guys. So I don't know if you've been getting bored with degrees, and we're hoping that there was hoping maybe there was something else out there that we could measure angles with. Well, you're in luck because today what we're going to talk about is we're going to define this idea of a radian, and we'll see kind of what it means with degrees also. But the big thing, it's a whole new way of kind of thinking about distances, really, is how you want to think about it. And then radians will kind of come from that. So the first thing I want to talk about is the unit circle. So the unit circle, and we'll just see kind of how this lecture goes. I am pretty sure it's going to be two parts. We kind of have this idea of a radian and what it has to do with arc length. And then we have some applications of that where we'll talk about angular and linear speed. So that angular and linear speed will probably be the second part of this lecture. So again, a lot of these sections in this book and in this class will be broken up into kind of two parts just because there's a lot of material in it. So unit circle. So a unit circle is defined as a circle of radius 1 centered at the origin. And we kind of talked about that already when we looked at the last section when we were defining sine, cosine, and tangent of any angle. So let's kind of talk about the unit circle and again, the idea origin, the idea of this thing called a radian is going to come from this distance. So when I draw this, we really are going to care about kind of a distance around the circle more than anything. Oh, that for me was guys, that was pretty good. Now the problem is I have to draw a circle. And that is kind of a whole other thing in and of itself. So trying to get these distances kind of close. Oh man, I'm nervous. I want to see your circles from your notes. Oh, and look at what I just did. That's even worse. I'm sure there's something in this I'm sure there is something in this program that I use called Smooth Draw. Oh, guys, I gotta redo that. If you can fast forward here, you might want to do so. All right, let's see. All right, and then, yeah, this isn't so bad. I'm nervous a little bit, but that, it was going all right, and then that was it. Oh my goodness. Okay, hold on. I'm going to pause this for a minute. Okay, guys, I just spent way too much time trying to draw a circle, and then I just went to Desmos and did one and copied it in here. So it was very good that it was paused there, and I apologize for, everything up till then. And I'd love to see your circles and see what they look like. Okay, so here's my unit circle. This is of radius 1. I'm so sorry. So this is at 1. I just haven't marked it. Okay, so we're at 1 and -1. That's supposed to be purple. 1 and -1 here at these points. And when we talk about this idea of a radian, again, we're talking about a distance. So let's talk about the distance around a circle. So we know that the distance around a circle, right? Circumference then of a circle is 2 pi r, right? Or pi times the diameter. So in this case, in the unit circle, if I want to describe the circumference of my circle, well, my radius obviously is 1, and so what is the circumference of my circle? We are going to will be 2 pi. Okay, so I know that all the way around, if I took an angle or if I looked at the distance all the way around the circle, sorry, now I'm drawing a circle again, that distance right there is going to be 2 pi. Okay, so what if we didn't want to go all the way around the circle, or what if we wanted to go further around the circle, right? So what do I know about if I just went halfway around the circle? So one full rotation, right? So one rotation would give me a distance of 2 pi. Starting again at this point right here, which is where we were used to starting with angles. What about half a rotation? What if we just went halfway around the circle, right? If I take a point on the circle and I just go halfway around, then this distance, that halfway around, right, would be obviously half of 2 pi. And so we're going to call this distance right here pi. Okay, so half a rotation around is going to be pi. And of course we can, you know, talk about more of that and look at different fractions, but we know halfway around is going to be pi. If we went just a quarter of the way around, or a quarter rotation, right? Starting here and then just coming up here, what would that distance again, and I probably shouldn't be calling it a rotation, but this distance along that I have traveled from the starting point right here to the top of the circle there, that would be a distance of pi over 2. Okay, again, that's a distance of pi over 2. So there are some interesting distances here that we can think about. So like if I wanted to go, let's say, right here. So if I look at this, if I wanted to go this distance right here, notice this is about, you know, if I broke it up like right here, do you see how that's about a third of the way to that pi over 2? So if I took 1/3 of pi over 2, what does that tell me? I'm actually 1/6 of halfway around. So what is this distance right here from my kind of 0 point here, which is the 0.10? This right here then would be pi over 6. And up here, if I look at this, that would be 2/3, right, of pi over 2, right? If I looked at this little point right here, I've gone 1/3, 2/3, and then if I was here, it'd be 3/3 of pi over 2. And so if my 2's cancel there, we see at that point right there, I have traveled about a distance of pi over 3, okay? Again, that's a third of halfway around. Okay, a third of halfway around. What else? What if I cut pi over 2 in half, right? So I cut that distance of pi over 2. I want to go half the way up there. So half of pi over 2 then is going to be pi over 4. And I'm going to tell you right now because you're going to see what's occurring here. If we looked at the angles there, right, my angle 45 degrees would kind of match up with that. But we don't know yet what that has to do with distance, because right now, what do I know? I know that, let me get a better color here. I know that this distance right here, this red distance here, is pi over 6, okay? Whatever my units are, so if whatever your units for 1 are, because it's 1 times that 2 pi. This distance right here is a distance of pi divided by 4. That's what that means, okay? And those are some pretty important ones, and of course we'll see that later, right? But that's what we mean by that. So let's look at a quick example really quick, and I just don't want to lose my circle here, so I'm just gonna erase this. Sorry about that. And let's look at an example of like how far around the circle we would go. So example, how far would a point travel? Around the unit circle. If it goes. So let's talk about some fractions. We all like fractions, right? Let's look at if it goes 1/4 of the way around. Let's say 5/12 of the way around. Or, I don't know, what about part C? What about 7/3, okay, of the way around the circle? All right, so how far would a point travel? So I actually want to know that distance, right, around the circle. If it goes around 1/4 of the way around, 5/12 or 7/3 of the way around the circle. So let's kind of look at the circle and let's talk about going 1/4 of the way. So I actually don't need to I don't even really need my unit circle to be able to do this, but what I do know is I know that if I go all the way around the unit circle, right? What do we know? We know that if I go here, we're going to have a distance of pi, right? If I go here, I know that I'm all the way out at 2 pi. Remember what we said, that's all the way around. What did we say right here? That this was pi over 2, right? And if you notice, so if I've traveled a distance of pi over 2, that's pi halves, half of pi. I add another half of pi, I'm at pi. If I add another half of pi, then I'm going to be at 1.5 pi's. Which sounds fine to me, 1.5 pi's, which is 3 pi over 2. And then again, if I go another half, I'd have 4 pi over 2, which is 2 pi. So 1/4 of the way around, I want 1/4 of the way around the whole thing. In mathematics, a lot of times means multiplication. So I'm going to take 1/4 of 2 pi. So how far have I traveled if I've gone 1/4 of the way around the circle? Well, we know what that is. That's going to be pi over 2. So I've gone pi over 2. What about 5/12? I'm going to take 5/12 times 2 pi. I can kind of cancel here and I get a 6. So let's talk about what this one means. So this says that I'm 5 pi over 6 around the circle. So I want you to think about fractions. It'll be okay. Think about fractions. Fractions are your friends, okay? Let's look at what this is saying. 5/6 of pi. So that's saying, so what would be a whole pi, right? If I went all the way around 2 pi and I think of it as 6, that would be 6/6, right? Of pi is exactly the same as 1 pi. So if I went 6/6 of pi, that means I've gone all the way along the top half of my circle. So what does that 5/6 of pi mean? Well, that means I haven't quite gone all the way to pi, right? I am still 1/6 of the way from pi. And we know that 1/6 of the way is about this distance right here. So that is the distance that I am going to be away from pi on the other side. So where is 5 pi over 6? Or it's going to be about right there. Do you see how I'm just going to be a little bit away? I'm going to be about 1/6 away. Oh, I didn't do that quite right. This should be matching a little bit, but that's all right. You understand. Let me undo that really quick. Oh no, I'm redoing it. This is just a great lecture. It's going to be one of my best ones, I think. So this is 5 pi over 6 here. All right, so so what have we traveled for that? I've 5/12 of the way around the whole circle is about that distance right there. And that kind of makes sense because if you take 5/12, well, 6/12 would be halfway around, right? So 5/12 would be, I'm looking it up on my calculator, about 41.6% of the way around the whole circle. So not quite half, right? Not quite half, but that's what we got. Let me undo this. Okay, let's look at the next one. So give myself some room here. The next one is saying what, and it's all fractions, and don't be scared of these fractions, you guys. They're just fractions of pi, really, once we simplify them. So look at 7/3. So 7/3 of 2 pi, okay? If I went 7/3 of 2 pi, 7/3 the way around, well, obviously 7/3 is bigger than 1, right? 7/3 is about 2 1/3. So I'm going around 2 times, right, and 1/3. But if I look at that, that's 14 pi over 3. And I actually, when I look at this one, I like to think about it more in terms of the 2 pi as opposed to pi. This would make sense, but remember, pi is just a half. So let's look at this one right here. So I want 7/3. It's going to be lovely. So 7/3 again is 2 1/3. So I'm going to go around once. I'm going to go around twice if this was like a lap that I was trying to go around if I was a runner. I'm not a runner. And then what is 1/3 of, what is 1/3 of 2 pi, right? That would be 2 pi over 3. So that would be 2/3 if you look at that. I'm sorry, yeah, right. 2/3 of pi. Yeah, so 2/3 of pi, right? That means I'm 1/3 away. So look at this distance right here was 1/3. That means I'm 1/3 away from pi. So I've gone all the way around twice, and now I'm going to come right here. and that's how far I'm going to go. Does that make sense? 2/3 of pi. So pi would be all the way around. This is 1/3 right here. I'm going to be 1/3 away from pi. I hope that kind of makes sense what we did there. Let me undo all of that. There we go. Get my nice circle back. So again, it's just fractions. You can think of it a lot of terms. You know, when nothing canceled here, I wanted to think of this as multiples of 2 pi. But a lot of times, especially if you're going to be less than 2 pi, it's kind of nice to think about how it might be multiples of just pi. Okay. All right, so that's a good time. You know, we don't always have to have distances in terms of pi either. You know, you can, if you think about this, how often do you go to, I want you to do this. How often do you go to Home Depot and ask them for, well, I need about 2 pi feet of something? That doesn't really make sense. So when we look at this a little bit more in terms of maybe what we're used to seeing when it terms of distances, and this is important too. So if I'm starting out here, this would be 0. If I look at, we know what pi is. Pi is approximately 3.14, right? So if I take pi, I'm putting this into my calculator, and divide it by 2. So if I've traveled up to here, this is about 1.57. Right? We obviously know pi is about 3.14. If I take 3.14 and add 1.57 to it, or just multiply pi by 3/2, right? I get about 4.71. And then if I take 2 times pi, so these are tangible numbers, it's about 6.28 or 6.28. Those are numbers that kind of mean more to us, right? If I were to go to Home Depot and ask them for a distance, I'm not going to tell them, well, I would love to do that. I'm not going to tell them 2 pi or something. So if I asked you, like, where would you be if you were to be, I don't know, a length of, if I wanted to go 10 around, 10 whatever our units are. What if I wanted to go 10 around the circle? Well, I know that I'm going to at least go once around the circle, right? So I've gone once around the circle. So there's my 6.28. If I take that 6.28 plus the 3.14, I'm at 9.42. And so why did I add 3.14? Well, here I'm at 6.28. If I add 3.14 to it, I'm at 9.42, and then I just need to go a little bit more, right? About half more. So I'd probably be, you know, somewhere here in the 3rd quadrant. I don't want to add another 1.57 to that 9.42, but I'm probably going to be right around here somewhere, and that's where I'm going to be for 10 length. So I really want you to think of these numbers. This pi really isn't a unit. It really does stand for that 3.14. So if I wanted to travel a distance of 10, I would be able to do that, okay, around my circle, because I know my circumference of my circle is 2 times pi, and pi again is this irrational number. It's a lovely number. That is about 3.14. You can do negative distances too. I know that's weird, but what that negative distance just tells you is go the other direction. So I could do a -10, right? I would go all the way around again. I'd go to here, and then I'd go just a little bit more. That would be a -10. I know that's weird. Again, go to Home Depot and ask for a -10 feet of something. They'll look at you funny. I get a lot of funny looks sometimes when I go to Home Depot. So that's what that kind of means. I hope that kind of makes sense. Now let's talk about what is really the important thing in this section. Not that the distance idea isn't important, because that's how we're going to define radians now. But we want to talk about radian measure. Okay. So radian measure, as when I was showing you all of those distances, really that's where our discussion of a radian is going to come, and that's what's going to kind of drive this discussion. So this idea here of a radian measure, oh yeah, there we go, wonderful. Let's put this over here. Okay, so this idea of a radian measure is we want to find, so just like I said, we could find a point where I have traveled 10, right? A distance of 10 around the unit circle, whatever our unit length is. What I want to do is I want to find a point on here where I have traveled exactly 1 unit of length. Okay, and when I say 1 unit of length, what we call that is we really call that arc length. So I want to travel exactly 1 unit of length. So I'm going to start on my circle. I'm going to come up. I'm going to go exactly 1. So remember, this is pi, so that's about 3. So I should be about, you know, if I look at that, that's about maybe a third of pi. It's not going to be perfect. It should be a little bit less than a third. So I'm actually going to move it a little bit. Let's move it down just a little bit more. So let's go right there, a little bit less than a third, but I know this is pi. So I want to consider this distance right here, and this is exactly an arc length of 1. Okay, so this distance right here has an arc length. Arc length is just a distance along a curve like that. So this has an arc length of 1. And this is going to be the important part of talking about radians. So I have an arc length of 1, and I am going to draw an angle from my origin through that point where I know I have an arc length of 1. And I am going to describe this angle right here as theta, and I am going to define theta to be what we call a radian. This is what we define. Theta is 1 radian, okay? And this is a new way to measure angles. So that is what we mean by 1 radian. So the measure of the angle is 1 radian. The radian, you kind of see the word, it's kind of derived from radius, and it kind of means that it's 1 radius along the circumference of the circle. And that's what we've done, 1 kind of radius of the circumference of the circle. That determines our angle, or 1 radian. 1 radian is about 57.3 degrees, which makes sense, right? We were just saying that it should be about a third away from pi. And this is almost 60 degrees, and 60 degrees is a third away from 180. So that kind of makes sense, right? If I do 1 more radian, I would add, you know, another 57.3 degrees. So, you know, 2 radians would be about right here. This is 2 radians. 3 radians, where would 3 radians be at? Well, 3 radians isn't quite pi, right? Because pi is a distance of 3.14. 3 radians is a distance of just 3. So this would be 3 radians. And you can kind of see that. Where would, if I were to be really, really close to 2 pi, how many radians would I go to get about to 2 pi? Remember, 2 pi is about 6.28. So I would need about 6 radians. If I looked at that angle right there, that's going to be about 6 radians to get to 2 pi. So I hope that kind of makes sense. That's just kind of the definition of what a radian is. So there are some important relationships between radians between radians and degrees. And so let me paste that again in here, and let's kind of talk about that a little bit better now that I have a circle. Okay, so when we talk about radians, so I'm going to go ahead and put the angle, and then we'll talk about the radians also. Okay, so this right here obviously is 0 degrees, and it's going to be 360 degrees also, right? And so it's 0, and it's also 0 radians. Radians doesn't have a little degree symbol, so radians are is just a distance, and it doesn't actually have any units to it. That's kind of the great thing about radians, is they have no units to it. So we know, of course, up here is 90 degrees, right? Up at the top here is 90 degrees. We saw that before, that was pi over 2 radians. And we actually will not be putting radians after this every time, but I'm just going to do that for emphasis here. And what we find that was about 1.57, if we think of that in numbers and not the pi, right? Because 3.14 divided by 2 is about 1.57. What about over here? This was this is obviously 180 degrees. That's going to be the same thing as pi radians, which we know is approximately 3.14. And then here, this was 270 degrees. So 270 degrees is going to be equivalent to 3 pi over 2 radians, right? I've traveled a distance of 3 pi over 2 to get here, and so that's what we define that angle to be. That distance is 3 pi over 2, and so my angle is going to be 3 pi over 2 radians. So remember, all comes from a distance around the circle. That's where we're getting these numbers. 3 pi over 2 radians is approximately, we saw that before, 4.17 radians. And then if we go all the way around, 0 degrees, that's going to be the same as 0 radians, or 360 degrees, or 2 pi radians, or we could keep going, right? We could have more. We're at about 6.28 radians. Okay, so those are kind of some of the big ones. Some other ones that are kind of important that I'm going to go ahead and put on here that we'll talk about later, but this is going to be 30 degrees. And 30 degrees is going to be the same. We saw this before as pi over 6 radians. If I cut pi over 2 in half, this is 45 degrees, and that's the same as pi over 4 radians. And then this right here we saw was pi over 3. It was about 1/3 of the way to pi, and that's going to be, whoops, if I stay with what I've been doing, I should do degrees first. That's 60 degrees, right? Which is pi over 3 radians. Okay, so these guys are going to be the big ones because we remember how to do reference angles and stuff with that, so we're going to be doing that as well. Look at this, makes sense because look at what we have here. We have this relationship between 180 degrees is equal to pi radians, right? So if I looked at that pi over 6 and I wasn't sure exactly where that was, I know that pi is 180 degrees. So I know that pi over 6 is going to be 1/6 of 180 degrees, and that is 30 degrees. So we need to know how to convert between these two. So let's talk about, let's write down a couple formulas. We don't have to have formulas if you just remember that pi is 180 and vice versa, but sometimes it's nice to have a nice little formula or rules to write down. So converting between the different degrees. So converting from radians to degrees or vice versa. And where that all comes from is if I know, remember, we know that pi is equal to 180 degrees. So if you divide both sides, so I'm going to divide both sides by 180. And so if I do that, that means that pi radians, again, I'll just put radians for now, but we're going to drop that eventually. If there is no degree symbol, then we assume it's in radians, okay? So if I divide both sides by 180, I get 1 equals pi over 180. Or if I divide both sides by pi, then I get 180 degrees over pi radians. And these are both equal to 1. It's just like when you convert, in like one of my problem solving classes, we talk about converting from like feet to yards or yards to inches or something like that. And when we convert to those, we multiply by a conversion fraction, right? That really just equals 1. And because pi radians is defined to be the same as 180, when you multiply by this, you're technically just multiplying by 1. So to convert from, and again, I don't really want you to memorize this, but degrees to radians, you're going to multiply whatever you have. So let's think about what we want to do. We want to get rid of degrees and we want to get radians. So the thing that I want to get rid of needs to go in the bottom. So I'm actually going to multiply by, I want the degrees to go in the bottom. I'm going to put pi over 180. Again, I'm being lazy. I'm not going to put the radians. And then to convert from radians to degrees, let's think about this. I want to keep my degrees. I want to get rid of my radians. So whatever I want to get rid of goes in the denominator. What I want to keep goes in the numerator. If you can just remember that, you don't have to memorize. You don't have to memorize what I just wrote down. So let's convert. Example, convert to. So let's convert 2 radians. And usually if we can, if you can, what I would like you to do is I would like you to leave it in terms of pi, but you're not always going to be able to do that. So let's convert to radians. Let's start with something like, I don't know, what about that 7 pi? Let's look at 7 pi over 3. Okay, so 7 pi over 3, I want to convert it. It's already in radians, Sarah. A little too excited there. All right, so let's convert 2 radians. That means I need to give you a degree. Let's look at, I don't know, 200 220 degrees. Okay, so I want to convert 220 degrees to radians. So I'm not even going to worry about up here because I don't like memorizing things. So what I do know is that if I have 220 degrees, I know I'm going to multiply by pi over 180 or 180 over pi, one of those, right? But I know I want my degrees to cancel. So I'm going to take 180 degrees, I'm going to put it on the bottom because do you see kind of how the degrees cancel? And I'm going to leave pi on the top. And I'm going to go ahead and I'm going to write this as a multiple of pi if it makes sense. And in this case, it sure does make sense because I don't have some weird decimals. So I'm going to simplify. I'm going to cross off the zeros and then I'm going to divide everything by 2. So it looks like I get 11 pi over 9. And this, let's see, does this make sense? So 220 degrees, right? I would go 180 degrees and then I would go about 40 more, so not quite halfway. That's going to be 220 degrees. And so 11 pi over 9, does that make sense? Well, remember, this right here would be 9 pi over 9, right? That'd be one whole pi. And then I'm going about 2/9 of the way. 2/9 is about 0.1, about, you know, 10% or 20%, excuse me, 0.2, about 20% or a fifth of the way. So yeah, I think that makes sense, right? And it does. So think about what that means. B, what if I had a negative 43.21 degrees? Okay, and I want to convert this to radians. So I'm going to do the same thing here, but in this case it might, and the negative just comes with me. Remember, the negative just tells me that I'm going to go clockwise instead of counterclockwise, and I'm still going to have pi on top and 180 on the bottom. And I could leave it like that if I wanted to just leave it as a multiple of pi. I could leave it as negative 43.21 divided by pi divided by 180, or it might make sense to kind of talk about this actually in radians. So I'm going to do 43.21. I'm going to first divide it by 180. It doesn't matter which one you do. And then I'm going to multiply this by pi. And I get that this is about a negative 0.75 radians. Okay. So where is that? So negative 0.75 radians. Remember, 1 radian, right? It's about 57 degrees, or it's the distance to go. And remember, I'm going... so 57 degrees would be, you know, what, about right here? And I'm going in the opposite direction. And so I'm not quite 1 degree, so it looks like I'm about right there. And that makes sense. 43.21 degrees, I'm going to go in the opposite direction, right? That looks a lot like 45, but I should be pretty close to 45 because it's a negative 43.21 degrees. Up here, what was this radian? I just want to show you really quick. 11 pi divided by 9. So 11 divided by 9 is 1.222. And then let's multiply that by pi. So how many radians is this? This is 3.83 radians. And remember, we know that this right here is 2.14. So it's a bit more than that. 3.14, obviously, which makes sense. Okay. And then let's go ahead and go the other way. So let's go convert. Now we'll go back to what I was doing, 2 degrees. And this is going to be something that you're going to probably do quite a bit because you might not be totally comfortable with Radian Measure for a while, so you're going to have to maybe convert it to degrees to really get a feel for where it's at. But I want you to get in the habit of I want you to work with this enough so that you don't have to convert it to 2 degrees every single time you want to deal with something like this. So 7 pi over 4, what do I want to get? I want the degrees, right? Show me the degrees. I want the degrees. I want to get rid of the radians. So 180 degrees is the same as pi. When you're converting from radians to degrees, really what I do is I just make that straight substitution. I know pi is equal to 180. So if I have a pi, you don't always have a pi, but if I have a pi in as the angle that I'm given for radians, I just replace it. So look at what I have here. So the pi's cancel. 4 goes into 180 45 times, and then 45 times 7 is 315 degrees. Okay, does that make sense? So 7 pi over 4, I want you to think about this. So this would be 4 pi over 4, right? And if I added another 4 pi over 4, which would give me 2 pi, guys, this is going to be 8 pi over 4, right? 4 goes into 8 2 times. So that's 7 pi over 4. That's 45 degrees. That tells me I'm 45 degrees. I'm a pi over 4 away from 2 pi. Sure enough, that makes sense that that's 315 degrees. Okay. What about something like 9.6 radians? So this is the case where it's not as easy for me to just replace the pi with the 180. So if I were to do 9.6 radians, again, I want to convert 2 degrees so I know my degrees are going on top, and my radians, which is just going to be that pi, is going to go on the bottom. So what am I going to get here? I got 9.6 times 180. Okay, and now I'm going to divide by pi. And what do we get? We get about 550 degrees, 550.04. So we'll just round to about 550 degrees. So let's see if that makes sense. So 550 degrees. So there's 360 degrees, right? 550 minus 360 is 190 degrees. So I'm going to go just a little tiny bit more. Okay, then 190 degrees. So this is going to be my 550 degrees. And does that make sense for the 9.6 radians? Well, remember, if I went all the way around, this was 6.28. Okay, and then if I added 6.28 plus another pi, so plus 3.14, yeah, this right here, this, if I've gone all the way around and go again, this is 9.42 on this side, and then I'm just a little bit more than that. So start thinking about that. Start thinking about that. So again, I just want to emphasize, and I've said this already, but if no units are given, so no degree sign, we assume that it is radians. It is in radians, okay? Okay, we're almost done. 36 minutes, my goodness. This is why I don't know, I think my lectures are getting longer, but this is why we're breaking this up into 2 things. So, okay, last thing. What I would like to do is just bring back my unit circle. Okay, I'm gonna have to maybe make it a little bit bigger next time. And I just want to kind of label these a little bit so that we get used to, I want to get used to where my radians are. And let's just do radians. So this is going to be 0 degrees. This guy right here is the same as 30 degrees, or that's going to be pi over 6. Okay, this right here is 45 degrees, or 1/4 of the way around. So that's pi over 4. And this guy right here is pi over 3. So I always get those two mixed up. I want this to be pi over 3 and that to be pi over 6. But remember, you're taking a smaller chunk of pi here. So that's pi over 6, right? I'm only taking a 6. Here I'm taking a 1/3. This is going to be pi over 2. Now let's see what happens with these right here. We know that this is pi, obviously. So let's look at this. If you look at this one, I'm pi over 6. This is 30 degrees. I'm about another 30 degrees away from 90. So that would be 120 degrees. Oh, we know that's 120. I need to be in radians. My bad. Okay, let's think of it in the thirds. Excuse me. So this is a 1/3. If you look at that angle right here. And what I've done here is I've basically added another 1/3 to it. And do you see I'm a 1/3 away from pi? So because pi would be 3/3, this guy here, let's actually put this up so we have a little bit more room, is going to be 2 pi over 3. Okay, this guy right here, this is going to be, if you notice, it's about 1/4 of the way away from pi. Again, if that was 4 pi over 4, then this guy right here would be 1/4 away from pi, so that'd be 3 pi over 4. And then finally, look at this guy. This guy, I'm the smallest distance away from pi. That means I'm a pi over 6 away from pi, right? So I'm not at 6 pi over 6, I'm at 5 pi over 6. All right, so let's keep going. And once we get these all done, we'll be done. So look at this angle right here. I've really just taken this distance and added that distance onto pi. So that distance we know is pi over 6. Oh, come on, go away. Okay, that distance is pi over 6. So if this was 6 pi over 6 and I add another pi over 6 to it, I'm at 7 pi over 6. See how that's working? This guy right here, it's about a fourth of the way, right, around the quarter circle there. And so if this was 4 pi over 4 and I added another pi over 4, we would be at 5 pi over 4. And then if I look at this one, if I'm adding this distance right here, right, what is that equivalent to? That's equivalent to this distance here in the first quadrant. So that's at pi over 3. So if I had 3 pi over 3 and I added another pi over 3, I'd be at 4 pi over 3. It's all fractions, guys. That's all it is. It's so exciting. I know you're excited. This is 3 pi over 2, remember? And then let's just kind of finish this out. These are not perfect, but oh well, that's okay. So let's look at this point right here. Now let's see about it being away from 2 pi. So look at that distance right there. That's the same as pi over 3. So what I want you to think about is if that distance is pi over 3, 2 pi would be 6 pi over 3, right? And pi over 3s, that's kind of what I'm thinking of. So 6 pi over 3, what's 1 pi over 3 away from 6 pi over 3? That would be 5 pi over 3. Okay. Likewise, right? What about this one here? This is again about that fourth. What is 2 pi in terms of fourths? That's 8 pi over 4. So I'm 1 pi over 4 away. So that's 7 pi over 4. And then the last one, and then I'm going to stop talking, I promise, because we're at 40 minutes. I have a good time though, that's the problem. I'm that tiny little distance away, which is equivalent to this distance, or it should be. I know it doesn't look like it. But what is 2 pi in terms of 6? 2 pi would be 12 pi over 6. So if I'm a sixth away from 2 pi, that, my friends, is 11 pi over 6. Yay! And then, of course, what is 0 degrees? 0 is the same thing as 2 pi. Come to know and love these. You will be working with them quite a bit. There's some other examples. You can look in the book if you want, or look at the fun sheet, but we can find angles that are coterminal because it's radian measure, then you're going to use pi over 2. I'm sorry, I was thinking supplementary and complementary. You're going to do that also, but coterminal, you can, go both ways. For example, I said I was going to be done, but let's say pi over 6. What's a coterminal angle to pi over 6? Well, if I go around the other way, right, to pi over 6 right here, I'm pi over 6 away from a negative 2 pi, so that would be a negative 11 pi over 6. So that's some of the stuff that we can do. Or let's find a coterminal angle to 2 pi over 3. So if I go this way, right, I'm a full pi, right, and then I add another 1/3 of a pi. So this would be negative 3 pi over 3 with another 1/3. That'd be a negative 4 pi over 3. Okay, or you can just subtract 2 pi and get a common denominator. So what do I mean by that? 2 pi over 3 minus 2 pi, which we know 2 pi in terms of thirds is 6 pi over 3, right? So it's just subtract 360 degrees. That would give me a negative 4 pi over 3. All right, I think you're probably done. I know I am. Look at the examples, look at the fun sheet, and let me know if you have any questions.